Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, you are looking at congruent triangle. This is a follow-up of the lesson, our previous lesson, where we looked at similar triangles. In the same order, we'll look at what the definition is, the terms we need to know, and then we'll look at 4 postulates that help us to determine whether or not 2 triangles are congruent or not. So without much I say or do, let's quickly look into it. Now, talking of congruence, we say 2 geometric figures are congruent. This is the symbol over here. If and only if they have the exact same size and the exact same shape. Take note, they have the exact same size and the exact same shape. Remember, for that is similarity, we said they can have the exact same shape, but probably they might have different sizes. Nevertheless, they should have the same shape. For congruent this time around, we need the 2 figures to have the same size and the same shape. If not, they are not congruent. Now, for this to happen, then for these 2 triangles we have over here, it simply means that all the 3 angles have to be equal. So if I take this angle here, it needs to be the same as this. This angle should be the same as this here. This angle should also be the same as this. Also, all the lines must be equal. Okay, so this should be the same as this. This here should then be the same as this. And then this should also be the same as this. That is the corresponding lines, you see. Now, with that said, let's quickly look at the postulates that help us to determine if triangles are congruent or not. So for a quick intro, the 4 postulates, the 4 congruence postulates are SSS, that is the side, 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 and then SAS, the side, angle, side, ASA, angle, side, angle, and then AAS, that is the angle, angle, side. We'll look at each and every one of them, and then we'll look at how they are applied as well to determine whether or not 2 triangles are congruent. So for the first one, now the first postulate, which is the very straightforward one, that has to do with you being given the 3 sides, or altogether the 6 sides of the triangle. So as you can see, it says all 3 sides of one triangle are congruent. So congruence here means equal. So to the 3 corresponding sides of the second triangle. So all this postulate is telling us is that if you are given all the sides of the triangle, we've been given A, we've been given B, and then C of one triangle. If we are saying B over here is corresponding to F, then it simply means that the measure of A, sorry, it simply means the measure of B, should then be equal to F. You see, and also if you are saying A corresponds to E, then what it means is the measure of A should be equal to what? E. And finally, if you're also saying C corresponds to J, then the measure of C should be equal to what? J. If you are able to prove this, or you're able to show that the corresponding sides are equal, then we can say the triangles we have are congruent. You see, they are the same shape. And you would see that over here. So we said C to J. And if you look at it, if I just come and put it on it, you realize that they are actually the same. You see, the corresponding sides are the same. So that is what the first postulate is saying. Try and be able to prove that the corresponding sides are the same per their measurement. Your conclusion will be that yes, they are congruent. Let's look at the second postulate. Now, for this second postulate, we apply it when you are given a side and then another side. with the angle in between the two sides in question. Okay. So the postulate says if two sides and the included angle here, we mean the angle between the two sides. So we've been given this side and this side. My included angle is going to be this because it is between the two lines we were given. Do you see? So if two sides and the included angle of one triangle, so of this one, if they are congruent to the corresponding part of the second triangle, then the triangles are congruent. So if this side is corresponding, that is, it corresponds with this, and we are seeing they are the same. And this other side also corresponds with this, and we are saying they are the same. In addition to that, their included angles are also the same. Then the triangles are what? Congruent. Hence, we wouldn't have to look for all the 6 parts, that is, all the 3 sides and then all the angles, but just with the 2 sides and then an angle, we are good to go. Specifically, the included angle. That is what the third or this second postulate says. The third postulate also say that. Now, the third postulate, as you see on your screen, is also a very straightforward one. And that has to do with you being given 2 angles and then a side. Now, this side we are talking about is an included side. That is the side in between the angles. So it says if 2 angles and the included side of one triangle, so of this one, these are the 2 angles and then the included side, are congruent to the corresponding part. So this side here corresponds to this side over here, you see, and then this angle here is actually corresponding to this angle over here, and also this angle here corresponds to what? This angle over here. So what this postulate is saying is if the corresponding angles and the included sides are congruent, then it simply means the triangle or the 2 triangles are what? Congruent. As simple as that. So you can, if you're able to confirm this with 2 triangles, if this triangle here is our A and this is our B, then you can say triangle A is congruent to what? Triangle B. As simple as that. We'll look at the last postulate. So for the last postulate, or let me call it a theorem, it says if 2 angles and a non-included side, and since we have looked at what an included side is, for the non-included side, we simply mean the side that is not between the 2 angles. So if this is my angle and this is also my angle, this side here is between the 2 angles, you see. But this side, on the other hand, is not. So we call it the non-included side. So the postulate or theorem is saying if 2 angles in a non-included side of one triangle are congruent to the corresponding part of the second triangle, then the triangles are congruent. So if this one is corresponding to this, and then this angle here is corresponding to this with respect to the corresponding sides, and the non-included angles are also, the non-included sides are also equal, then it simply means the whole of these 2 triangles are also congruent. These are the rules or the postulates you will use as supporting answers when being asked that are these 2 triangles similar or congruent. So you should be able to understand and explain these postulates. We are ending this lesson here. In our subsequent lessons, we'll solve questions that has to do with application of these postulates. Without much ado, if this is your first time visiting this channel, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. This is Have Beyond Numbers, where we learn maths the easy way. Bye for now and stay safe.